Our Fluent final project. This is our wind tunnel project. Here's the handout right here. You can see we have all this, and actually we're gonna do. Well, I'm gonna do the bonus part. Only because I haven't done it yet, and so I figure I'll kill two birds with one stone, record the video, and do the bonus part. So what I've done so far is I just copied my geometry over from my my wind tunnel project from here. So hopefully when we jump into geometry, most of our stuff should be there. I also cleared out all the data from the mesh, the setup and the solution. So we hopefully won't have any problems going into that with an updated geometry. So the first thing I'll do is just delete this. I'm gonna have to recreate that anyhow. And we can start editing this sketch. So I'll drop a line here and somewhere around there. I'm gonna put mine directly in the middle vertically, which I believe, if you do the math, is like 0.3048. 0.3048, which looks close. I might be off by this one too, but it looks close. And I'm gonna push it sort of to the back third of the test section, just so that that flow is fully developed by the time it gets there. And I won't have any problems with that. Sorry about that. So we'll go ahead and grab our circle tool, drop a circle here, and we can get rid of those unneeded lines. And we can make a surface from the sketch and generate. So we're all done with that. Now to the mesh. I don't know whether or not it's going to save my previous mesh data. Yeah, so it'll tell you that you're missing some stuff because obviously it's a copied thing, but yeah, so it actually does have that. So we can. This is my previous meshing procedure. I don't know what this box is, but we can do this, select that, and apply. And let's just go ahead and try to generate that mesh and see what happens. You can see that's telling me that's old geometry, but I mean, we'll see. We'll see if it lets me do it or not. Another thing we're also gonna have to check before we go forward is to make sure that all of our named selections over here are still named in the right locations. But we'll let this mesh. The mesh method I used here was the triangles method, which is just it's a little different from the orthogonal one that we usually do. I'm not entirely sure what to think about that pink box, but mesh looks pretty decent. Looks really good around the circle. Yeah, I'm happy with that. So we'll zoom back out. I don't really see any mistakes in there. The triangle method is just a little different from the orthogonal one by making triangles instead of squares. And I've had less problems with it. I think one, because the lines aren't mostly parallel to the flow, they're kind of all over. So you get a better mapping, I guess you want to call it, whatever. But let's check on our name selections. It looks like they're all missing. So we can do this and possibly just seems to work. So I named that here the test symmetry. This here is the contraction symmetry. Sorry. Okay. The expansion symmetry is obviously just this. Outlet. You can see I did 2 lines here, like to make, because I had a center line, but it doesn't really matter. And then lastly, the inlet, which is the same deal. I had to do 2 lines. I didn't have to, but I did. So hopefully now that's all named. Trying to think. I think that should be really it. You want to look at some of my mesh settings here. I used triangles, and then I did 5 millimeters for the element size. Trying to think if I did anything different. I did turn on adaptive sizing, but it didn't really do much. So that's pretty much it. Yeah, we can go back into Workbench and update that mesh. For our setup, we're on 4 processes. I see a lot of people do double precision, and I don't know why. Because I mean, for our purposes here in this project, we're not we don't need double precision. So it's just gonna take longer. So I'll do single precision. There's really, I mean, we're not looking out to 15, 16 decimal places in this anyway, so there's really no purpose to do double precision. Hopefully, jumping into Fluent, a lot of our plots and our contours are already saved. So when we just run, we'll have all that, and we can just sort of update them a little bit, and they'll work out. But we will see. Okay, I don't see our arrows coming in and out, but we'll check on our, well, first we can check on our model. It should be a K epsilon. Yeah, just one of our turbulence models, K epsilon, enhanced wall treatment, pressure gradient, yeah. So it's just one of our turbulence models. Materials is air, so we don't really need to. We'll check on this. Let's see. It's at 25 right now. We'll start with 10, just because that's our first case. Make sure our outlet's a pressure outlet. Oh, whoops. Sorry about that. Yeah, it's a pressure outlet. I did notice you should really make these walls. Even though I named them symmetry. Okay. Check on our reference values. We can compute from the inlet. And that's all good. Yeah, I really think that, I mean, it should have saved all of my things, so even if I'm missing something, I should be good. So we'll go ahead and initialize. Hope that it converges. Okay. And for our calculation, do 300 iterations. Yep, everything's saved from my last one. So I'll go ahead and run this and check on our residuals. In my previous ones for like the 10 and 25 without the object, I didn't have exactly convergence, but I mean, we'll see here, but they were steady for so long that after 300 iterations, I considered that good. I didn't think it was going to change anymore after that, so I think we're good as long, even if it doesn't converge. We'll have some oscillations probably, but it'll stabilize and hopefully not change. I will say it definitely takes significantly longer when you have upstream data. Like if you're starting this from scratch to do another version versus like updating the one you already did, everything takes like significantly longer. So if you do it my way, just be aware of that. As you can see, it's running pretty slow, but we're also doing 300 iterations, so. And you can kind of tell here it's not gonna converge. You can see them all kind of, they're stable. I mean, they're oscillating, but they're stable. But it doesn't converge. And from what I've learned on those Fluent courses is that if you're relatively sure that it's not gonna change, even if it doesn't converge, it's okay, basically. From what I understand, I could be wrong, but I took those Fluent courses, innovation, whatever, to help me with this projects. And that was one of the things I took away from that. That's why, I mean, it stabilizes around 75 to 100 iterations, but you run it a little longer just to make sure it doesn't change values later on. Almost done here. Okay. And that's it, making all the plots that I already have. So that's why it probably took so long. So we'll go ahead into, I believe it's graphics. We'll get our contours. We can check out a pressure contour here. Static pressure. We'll see if I might need to select more. Yeah, I do. So I will select some of these bodies. Just select them all. Yeah, that'll give us a little better. And we can just kind of just make sure that our model is correct. By just taking a look, so I'll grab this thing here if it lets me. I mean, that's kind of what you'd expect. You have a high pressure region coming in, and this happens to me all the time, but we'll go back into here and compute and save and display. So it's kind of what you expect, you know, the high pressure region coming in goes down to a lower pressure region in the test section, and you can see you have some really low pressure zones around here, right where that flow is accelerating over that object or whatever you have. Definitely have some high pressure here because it's going to be stagnation. I'm surprised there's not a larger low pressure region behind this, which is interesting. So let's check out let's just make a new contour for velocity. Velocity magnitude. Yeah, I'm go ahead and just select them all again. Yeah, I mean, that looks pretty good to me. That looks like definitely more of a defined wake region, which I'm surprised we didn't see that in the pressure contour. But yeah, we definitely have, you know, some low velocity and some turbulence for sure across that. So let me just check real quick. Let's see, we need pressure coefficients, but for now, I'm going to stop because that's going to take a little bit longer, but that's our model right there. You can go through Fluent or post results if you want to. You can update your post results and get all your graphs and and write all your reports and export them into Excel or whatever you have. But that's going to be it for my video today, so thank you guys, and that was my Fluent final project.